The purpose of this lecture, if I ever have a purpose in any of my lectures, is to really kind of show you the landscape to which you can commit yourself to be a steward of the earth. And so what better way than being the steward of the earth than through planetary healing? And the message that I really want to convey tonight is that there are many different points of entry depending on your talents and your interests. The ancient alchemists had a phrase for the kind of work that I'm talking about. And the alchemists just simply called it the great work. It's a kind of a lifetime journey with meaning. And so that's what I'd like to talk about tonight. The beginning of it all is the healing of the waters. And the importance of healing the waters is the water is the basis of all life. And the quality of water determines the quality of all life. So if we are surrounded by a toxic soup, that's going to have an effect on not only ourselves but our fellow creatures. If, on the other hand, we're bathed in pure waters, then beautiful things can happen. This is basically a toxic hellhole. All of the priority pollutants that the EPA ranks as the nasties, the top 15 nasty uglies, is floating in that pit, in that little bucolic town, on that bucolic spit of land known as Cape Cod. And it receives waste from an ungodly diversity of sources. That pit is also, as you remember, in a hole dug out of sand, coarse sand. And as you also will remember, it's only 8 feet above the drinking water table of that town. So we really know how to do ourselves in. So the story, as in all these stories, begins with the sun. The idea of using sunlight. I think that when you're thinking about designing or planning your future, make sure that sunshine is an ally in almost everything you do. And the idea was to try and find some way in which these could be transformed, that toxic hell could be transformed into pure water. And so there are the tanks that allow sunlight to come in a multi-dimensional way. Unlike a natural pond, the sides as well as the surface is exposed to sunlight. The other part of the story is that we do not know enough, any human being or all human beings collectively, to treat that waste. So in order to be successful, we have to bring together life forms from all the kingdoms of life and place them in these vats with this waste. That's the key. And you also need to go to many different environments. And what happens in those environments is that there are literally thousands of species of organisms, very much like what you did with the seeding on your eco machines. These thousands of species of organisms are brought together and they create new kind of communities that are actually not seen anywhere else on Earth. The species are recognizable to taxonomists, but the ecologies are new. And this is an extraordinary set of circumstances. What this tells us that is complex systems theory, when applied to large aggregations of organisms from many different kingdoms of life, have self-designed, self-organizing, and self-functioning properties that are truly remarkable. And then, of course, the idea of back to sunshine again, of converting some of that solar energy through these higher plants that are racked and floated on the top to produce chemicals from their roots that go into the water that feed the life forms within. In other words, they're not only feeding the life forms within, but they're also protecting the surface of the water from exhausting toxic compounds into the atmosphere. There isn't a conventional sewage plant in this country that doesn't blow off into the atmosphere crap. And this is designed to not do that. And then there is the marsh system on the right. And the purpose of the marsh system is to incorporate into the process both sand filtration and also the idea that there are higher plants, such as the bulrush, which have the ability to crack down complex organic molecules. And so this combination of the sand and the higher plants is a very powerful system. There's also sections of gravel in that, I should add. And then after 10 days, pure water. Really nothing short of a miracle. All of the priority pollutants are gone but one, which is 99.99% removed. The heavy metals have gone from the water at meeting drinking water standards. So nobody yet knows, although Anthony McGinnis is beginning to decode some of this information, just how it's done, which organisms play a part. But what Anthony is recently finding out is that there are some organisms that medical people are interested in that cannot be grown in the laboratory, but are being grown in the eco-machines. These are the repositories for organisms they believe they'll need in the future. Then the idea of dealing with cold climates. And this is the eco-machine in South Burlington that treated 80,000 gallons of sewage. And it was where we focused a lot of research on the use of higher plants in the transformation of waste. And some of these plants are extremely valuable for medical purposes, or for beauty like flowers, or for growing plants that can be used to repair damaged environments outdoors. Again, it's the same cellular design that you saw in the original experiment many decades ago. The same idea that ecologies can organize themselves in relation to the strength and the quantities and the type of waste at each stage, in this case, the 9-step process to pure water. The EPA, when we did this experiment, said that these things wouldn't function in winter. The top line is a 3-year measure of the dirtiness of water, suspended solids, and from left to right. And the bottom line, right down on the bottom, is the clarity of the water leaving the building. Note that it's just as clear in January through March as it is in August. Again, this is the organic loading, or the BOD. And again, the top line over a 3-year period of what's coming into the building, and the bottom line representing what's leaving the building. Again, the same thing. The organisms that break this down are functioning just as well in the winter as they are in the summer. Again, proof of that's not a restriction. And then finally, ammonia. And the reason why you measure ammonia in a system like this is because ammonia is toxic to a lot of aquatic life, plankton, zooplankton, and small fishes and things like that, in relatively low levels. And here again, this process called nitrification is working in the wintertime. Now typically, nitrification is considered the most thermally sensitive process in wastewater treatment. The reason we think no proof, just the reason that this works like this as well in the winter is because each season of the year we went into the wild and brought back wildlife exactly the way you seeded your organism, your eco-machines, and that allowed for this to happen. And so it has in it the intelligence of the seasons. And that's, I think, the critical factor. And they borrowed it from nature. It's not something that we could engineer in. And then the pure water at the end. And the byproduct here, normally sludge is a byproduct. But when an ecological designer sees sludge, they immediately think incomplete design. And so here, by taking these koi, mostly koi, but also goldfish, they are the ones that are consuming the sludges. This is downstream, so they're not exposing themselves to very many nasty compounds. And then they're sold out into the ornamental pond business. And the value of the fishes that are in that tank, there are 10,000 of them in that tank, basically could be as much as $1 million. So you're no longer treating waste, you're farming nutrients and you're creating an economy. So, and then of course the beauty that is the byproduct of the ecological process, and this valuable flowers. The canna lily obviously is not valuable because it doesn't function very well as a cut flower, but a lot of the others in there do. Over the years then, the process of designing ecological machines for the treatment of waste has moved towards in two directions. One is to reduce the energy input, to try and drive design towards carbon neutrality. Because if we could create carbon neutral designs, we would then take some of the pressure off the increasing CO2 in the atmosphere. Conventional sewage treatment plants produce a ton of CO2, from the bacteria that are inside them to the electricity that drives them. And here, the designer. And so this is a eco-machine for a campus in Rhinebeck, New York, the Omega Center for Sustainable Living. And it treats 45,000 gallons a day of sewage. But in order to move it towards carbon neutral low energy design, we married two different ecologies. The first is, which you can see here, is a series of constructed wetlands. And these wetlands do very effectively the preliminary treatment of the waste before it enters the building. So when the waste enter the building, you basically have this space that is polishing the water that's also used in this case for yoga classes and other classes. This is also a classroom as well as an eco-machine. And there's a picture of the interior with the cells where the final polishing is done. Incorporated into this design is some ideas that we borrowed from kelp forests. We've used this approach to completely eliminate what are called clarifiers, which is an expensive technology that is in most waste treatment systems. This building, by the way, is the first building in the world to be declared a winner of the Living Building Challenge. That happened this October, which is the next standard above the LEED standard. It also happens to be a LEED Platinum building at the same time. Also, the idea more and more integrating functions here, in this case, an educational building with the waste treatment plant itself. The next area that I want to talk about is healing people. And it's a huge field, but I want to start with the water, because the water is is the critical starting point. About a third of humanity do not have safe water. So mothers, when they go to collect water to cook for their children or provide them with water for other purposes, they know they're putting their children at risk. And so I want to talk about the work of your TA, Rebecca Tharp. She got very interested in this population of people, these all around the world who do not have clean water. It's like, I'm not kidding you, my son who's been in Haiti told me a story of where he saw raw shit floating down the street. The shit flowed through a narrow channel in a wall and over a little ledge, and at the base of the ledge, women were collecting water for their cooking and stuff. So it's tough. And so one of the things that Rebecca has been, concerned about is how do we create clean drinking water and develop a technology that costs little or nothing? Because all the big solutions that the big corporations have used for treating waste in the third world are really not working very well. I had a visit from a delegation from Mexico not long ago in which they described the fate of 5,400 modern waste treatment plants in the greater Mexico City area that were built recently but are not operating today. The reason was none of the communities could afford the electricity and the imported chemicals necessary to operate a modern treatment plant. So the sewage is just going back into the rivers. It's a complete failure of the technology. So what Rebecca did was to look at the existing small-scale, household-scale technologies that might work. And she found a technology which is very highly evolved. It's a slow sand filtration method. And here what happens is that dirty water flows through a sand filter, and on it is a biofilm, primarily of bacteria, but there are other organisms in it that help to filter out and break down the toxic material. But the water that comes out of these slow sand filters is not quite good enough. It's very good. It's fairly reliable technology. And so currently her research has gone to finding organisms that might help purify this water, the final bit, as part of the slow sand filter technology, to create an ecological technology on top of it. And so she's looked at the various classes of organisms, including the fungi and the aquatic plant, the Mentha aquatica. I think a few of you had Mentha aquatica in your eco machines. Yes, I did. There was at least one that had them. Both of these organisms have been found to produce powerful antibiotics. And in the case of Mentha aquatica, apparently an antibiotic that has a residual effect. In other words, whatever chemical it gives off that kills human pathogens stays in the water for a certain period of time. So down in the greenhouse, right next to where you've all been, has been her experiments in combining the sand filtration with, in this case, she's got an example of the oyster mushroom. If it's possible for us to be able to create a technology that's ecologically robust, that a person, a mother say, can go and get 4 or 5 gallons of polluted water and over a period of 12 hours make it safe to drink and wash with, then the beginning of the healing of people will really have started. Then the other great challenge forests is feeding people. Some of you sense already the great precarious position modern industrial agriculture is in. It is basically like those sewage treatment plants in Mexico City. It's on the edge, driven by a lot of energy and a lot of materials, including petroleum and petrochemicals like fertilizers and herbicides and pesticides. Smart money is betting these systems will begin to disintegrate around the world. The richest people will be able to hang on the longest. Nevertheless, we're going to have to rethink how we feed ourselves. And so from the point of view of your being planetary stewards, thinking about food is a good place to get started if your water is properly being served. And so what the important thing is to create new food webs in neglected sources. And maybe one of the most important areas of the future is to begin to understand urban environments and try and reconfigure these and redesign these and to become basically food growing centers. That would then permit the wildlands to be used for restoration and for the production of animals that might be needed to be added to our diet in a small amount. You know, the deer, the elk, the bison, the longhorn cattle, things like that, and the goats and the sheep and so on. But importantly is to begin to, as the human population goes urban, to urbanize urbanize our production of foods. And the example you remember from this course is the intervale. The idea of going from a relatively short growing season to a year-round growing season, using as the driver the excess heat from the power plant in the background. And with a group of students and one colleague, we sat down and began to fantasize what an agro-eco park would look like in the intervale. And we chronicled on the left all the activities that were going on, and then we started adding some of our own. And of course, one of them that we added was this new enterprise called the Intervale Brewery. We also fantasized a bakery and a restaurant and a food processing activity. And as a matter of fact, they were analyzed by a group of business students as to how applicable they might be to the intervale. And then on the right-hand side of this drawing, we fantasized byproducts that could possibly come out of using the waste products and the excess biological material from the other processes. In the center of that drawing, which looks like nothing, is actually the key part of that drawing. That is the mixing and blending of materials to serve various functions. And as we did that, we chose, as you recall, the waste from Magic Hat Brewery as a starting point. There were two components, the solids, the mash there, and the liquid component. And so we set two food webs in motion, one going to the liquid form and the other going to the solids form. Let's start with the liquid form. That's the facility for researching it is in the background there. And inside it were this eco machine, this 4-cell eco machine, which was designed to take the brewery waste, the liquid waste, run it through various food chains, starting in cell number 2 at the top and then going around back to cell number 1. And our goal was to see how many different organisms we could grow and what percentage of their food could be grown in the purification cycles within. And it turned out that this is what they looked like. Each one of these clusters is a 4-cell combination. The And a number of different products came out of it, including the tilapia fish, the yellow perch, the freshwater prawn, and about 4 or 5 species of crops, including basil, cucumber, tomatoes, and to a lesser degree, lettuces. So we were able to demonstrate to ourselves that you can take these strange resources and begin to create new food webs. And then when it came to the solids, again, there was a multi-step process to convert the solids to something new and something more valuable. The materials were placed in plastic bags, they were pasteurized, and a little oat straw was added to the waste, and the spawn of the mushroom started to spread really almost like lightning throughout this material and transform it biochemically and actually create inside the bags in a period of 2 weeks a new kind of feed that livestock like, including chickens, but the cattle were the primary recipients of it. And then, of course, out the side there were holes, and out the holes came the mushrooms, in which several crops per bag occurred before the whole system spent itself. And so what's left over then is a potential feed and mushrooms, which went into high-end restaurants because they're fresh, and oyster mushrooms have to be fresh to be valuable. And then that material was then moved into another environment and introduced to this organism, which is the red worm, or the compost worm. And they, in turn, in a period of a couple of weeks, converted the material again to a medium that was absolutely perfect for growing greens under winter conditions. And so there are the greens growing. They're in a greenhouse with a number of cuttings that occurred from the beginning of November right through to mid-May, when the outdoor farmers began to come into production. And so that material then, after producing greens all winter, was sieved and repackaged as a soil amendment. And in that soil amendment were the eggs of the earthworms, so that they were also inoculated with the earthworms themselves. And there's a architect's drawing of the whole facility. The left side is the restaurant, the market, the brewery, the bakery, all that kind of stuff is there. And then the right-hand side is the growing section. And this was the proposed plan, which still hasn't moved forward yet. But all of the people who worked on it ended up creating their own companies and are working on bits and pieces of the pie still and moving it into the economic realm. So if we can feed ourselves, and this is just a single example of what's happening. There's a very burgeoning field of urban agriculture developing, and it's developing actively all over the place. It's very exciting. One of its most famous advocates is a giant of a man called Will Allen, who is using it as a social and economic innovation tool in Milwaukee and now other places, right, Rafter? But the issue is the earth itself. Here's the problem. Don't you love it when somebody summarizes a complex problem in a few sentences? But here's the problem. Over the last 10,000 years, every time we've cut down a forest, every time we've plowed a field, every time we've left dirt exposed to sunlight or heavy rains, the amount of organic carbon in the soil has gone down. It started with agriculture, and agriculture is not the only villain, but it is the primary villain. And so the question then is, One has to take the position, I should add, my preface right now, is that that is where the carbon is stored, is in the soils. And every time the organic carbon level goes down in the soils, the carbon, the CO2 in the atmosphere goes up. There is a connection. So if we're going to save the climate, it begins with soils. And that means a worldwide soil building program. Now the good news is that ancient techniques of actually increasing soil carbon are being uncovered by anthropologists and others and soil biologists all the time. And new techniques are being found, so that for the first time in history, at this time in our history, we have a full toolbox of methods to go into really bad places and start ecologies. I'm talking about semi-arid regions, even deserts. I'm talking about blasted places like the mining lands in Appalachia. So if we can go to these places and do something remarkable, we can start a trend of a worldwide movement for soil formation to rebuild. And the side effects, by the way, food, clean water, there's so many side effects. It's unbelievable if we started this process. Now, I believe the way we can start the process is if we peg the value of all the world's currencies to the value of carbon. If carbon becomes the basis for currencies around the world, then that will allow even the poorest farmer in, say, Africa to be paid if they are rebuilding soils, and would allow somebody who is going in the other direction to pay a penalty for the damage they're doing to the atmosphere. But it takes something like a level playing field, and this may be the way to do it. And I propose that one has to focus on the positive side of this, to put literally several billion people to work. So one of the things that we talked about doing, a group of us here, was to go to some of the worst places on the planet and see what we could do. And this is just one of them. This is Appalachia, where over 1 million acres have been damaged by simply blowing the tops of mountains off, taking the coal out, and dumping what's left over down into the valleys. And these are just photographs. And so one of us, namely Samir Doshi, who's in this room, wave your hand so they can see you, decided that he was going to go to this place that you're looking at and make soils. And when he got there, the first thing he noticed is that's how they make soils. That's how the mining companies make soils. Notice all the erosion. Basically what they do is they hydroseed these areas with exotic plants and a little fertilizer. It gets a little bit of green fuzz on it, and they say we've rehabilitated it. You can't rehabilitate, of course, an Appalachian forest. They're magnificent. They are crown jewels in the earth's skin. But that's typically what they do. And what Samir said was, what are our great allies in this process? How can we go to that place and make soils and build an economy at the same time? And the first thing that he knew and understood was the fact that there are native warm season grasses, including switchgrasses, which have very tenacious root systems and which can basically penetrate down through rock and rubble and find nutrients where annual crops could not manage and exotic plants can't do. So the first thing he put into his toolbox was the idea of warm season grasses. The second thing he did was to realize, to harness the talents of a particular group of fungi called arbuscular fungi. And they have the ability to form soils in the presence of plant roots, very important to our future. And then finally, he added at the very start a small amount of fertilizer to keep the plants alive till they could start these ecological functions, like measured in terms of months. Although there were some controls without fertilizer, right? And, oh, I'm sorry, and also, why the hell did I forget that? And as a carbon source, he added charcoal, which is a compound, they're compounds, they're quite complex, but they have marvelous affinities to create stable nutrient associations in soils. In other words, to be the driver of soil formation. So this combination was able to produce that miracle on that land. So this was the end of the first year. I don't have a slide on the end of the second year, which is already past, but I imagine it's even more dramatic. So as you begin to think of these things, you begin to think of an economy to replace the coal economy. And here the idea is the biofuels, the grasses, the perennial grasses are being harvested. And they're being used to generate a fuel as part of their processing, and also to provide charcoal as part of their processing. So at least half of the charcoal goes back into the land to drive the process and increase the organic carbon content in the soils, and then the other half goes to begin to start new projects. And as you can see, over time, the soils are now good enough that we can start thinking about planting trees. And onto that landscape, you've got the agroforestry amongst the perennial grasses beginning to grow up. And then by that time, you begin to have animals on the land, which is also a very critical component. And as you begin to see, besides the biochar plant, we have the beginnings of an agro-eco-park. And then finally, in the year 16, this is not only function as an agricultural economic engine, but also a seeder of future restoration sites. And so the plan is to have a changing landscape, but at each stage, the amount of organic carbon accumulating in the soil grows up. And as it goes, it speeds up. And in the net of it is it begins to stabilize the Earth's atmosphere. I didn't mention Slurry, which is that's a river valley that is completely filled with coal slurry. There are trillions of gallons of it. It's really toxic crap. And so we decided that we wanted to see if that material, which is the plague on the planet, could somehow be detoxified. We only did one tiny pilot here, but we have been working on another waste. This is the work of Anthony McGuinness. And basically what Anthony set out to do was to try and eliminate a chemical from the mining waste. This is a Vermont mine here, from the mining waste that is both mutagenic, it causes mutations in organisms, and also cancer causing. It's a chemical that's used by the mining industry to make a higher grade material that they sell, so they get more money. And this material, which is called AEES, is at the heart of this so-called bullshit program to create clean coal. The way they plan to create clean coal is the way. And so Anthony has been working for the last several years, seeing if his eco-machines could break this material down. And it's become a very complicated story, but the bottom line is that in 72 hours, this compound is gone from the liquid portion. He's right now doing isotope work to find out if they've disappeared entirely, if they've been broken apart, snipped apart by the organisms within, or whether they've found themselves parked somewhere in the system. And we should know that within a couple of months. My point here is that even with this ghastly materials, we have creative possibilities. And then, again on the carbon story, you remember Chris Shanks, who visited us. There's the island in Lake Nicaragua where he's based. And I want to show you that and then show you this slide, which he showed to us. And the reason why I wanted you to see that slide is the bottom half is the rainy season, which is just ending. And the top half is the dry season, which would be the wintertime, roughly corresponding to our winter and early spring. Here is an environment that is so highly stressed that, it is very easy to destabilize it. And what happened in this place is that after World War II, the Inter-American Highway was built, and with the highway came the logging trucks. And with the logging trucks, the whole area was deforested. So here is the last of the great tropical dry forests, they're called, cut down in a short period of time. After that happened, the great herds of Brahman cattle were brought in to graze the imported African grasses that were brought in, that grew to some 12 or 14 feet tall. And when they burn, which they do because they light fires all the time, they burn at a really high temperature and literally burn up the soils. So between the sun and the dry season and the fires, the hot fires have been, now cool fires, that's a different story, and I don't have time to get into that now. But the point is, the soils have gone. And there are great stretches of this area where the soils are essentially gone. This is Miravalle, a volcano south about an hour and a half from Chris's place. And this is where I and my associates have a project. And we too are trying to create soils here. And in this case, we decided we would try a technique to reforest and build soils that's different than the one in Appalachia. Just different, not better or worse, we don't know yet. But what the plan was is that little individual trees, this is just the main house and the tended garden, but these individual trees start life in pots. They're underneath there, and they are potted in compost. There's not really fertilizer added, it's just sort of compost. And then half of them to that compost is added volcanic rock material, which we've got from a quarry, which is ground up and it goes through a 200 mesh screen. And so it's what they call rock flowers. And we add the rock flowers into the compost and compare with just compost. And there was a quite significant difference. We had a program to research this, but we didn't allow for the fact that the woman who's a wonderful Mexican lady didn't like our research protocol. And she was in charge of the horticulture. She noticed that all her little seedlings that didn't have the rock flowers were weak. And all the ones that had rock flowers were strong. So she said to us, "Screw you. I'm not torturing the plants like you scientists would do. They're all getting rock flowers. That's it. Sorry. That's the way I'm doing it. I'm the one who's doing it. Not you. You're just sitting there talking like you're doing it. What the project involves is 3 different kinds of trees. One is native trees that are threatened, slow-growing trees that you're in for the long haul. The second group is trees that are fruit and nut and fodder trees. And the third group is a tree and a shrub called Jatropha that produces a readily usable oil to drive the machinery. Now here we're not trying to create an export product with the oil because we've discovered already that Jatropha likes to live in an ecosystem, not a monocrop. And so we're just talking about creating enough oil for ourselves and our neighbors on this site, because all of the equipment operates off biodiesel. In order for this whole process to work, though, we have to have water to the young trees in the wintertime, in the dry season. So at the very highest point on the property, which is right here, we've made a pond, and using a series of solar panels, about 30 feet by 30 feet in size, water is pumped up from 100 meters down and slowly dribbles into the pond when the sun is shining. So that's enough water to keep the young seedlings alive. It'll take them 2 or 3 years before they're independent of the irrigation water fix. This is just some photographs of some of the young trees that are now a couple of years old. There's the Jatropha in the middle of the dry season. You can see it's really getting its butt kicked with the high winds and hot weather. Some more trees. And so another project in another part of the world, again with the same idea. There are lands in that area where we are that are really end-of-the-road kind of places in terms of their soils and their ability to support life. And so wonderful opportunities for people to do that. I'm going to end with the last one, which is healing the seas. I think the BP oil spill really affected all of us. The sight of those fires and those black clouds and the animals damaged, and God knows what we can imagine to the ecosystems around it, really was it really was quite horrendous. And I thought that we had the basis to figure out how to create a technology that could clean up the Gulf of Mexico and the polluted inshore oceans around the world. And I think projects like this in South China, the Baima Canal, where that open sewer right there and right there was transformed into fairly high quality water right there. And so water is moving by that. So why not create a technology that would move through the water? And so here's the idea, the concept that's evolving since late this summer. It's the Ocean Restorer. And Matt Beam, who's a former TA in this class, is working with me on this right now. He'll also be building the Eco Machine here at here this winter on the campus. The idea here is a number of things we're trying to do. First of all, the sails. The sails look like traditional Chinese junks, and the reason is for this adopting this strategy is they lend themselves to being handled like weather vanes so that they don't have to be taken down when you don't want to move. The other thing is that they don't flap, so that the materials that we are going to make these of are made up of photovoltaic materials. So each one of those sails is an electric power plant as well as a propulsion device. And the idea is this would be a hybrid vessel that is solar wind hybrid. And then that's a view of a head-on view. It's a multi-hull. And the reason why it's a multi-hull is because down between the hulls to a depth of 10 to 12 feet are going to be eco-technologies. And the goal for one of these is to treat 1 billion gallons a day. That's 1 billion gallons a day of polluted water, and which is a lot of water. And what will happen is that between the hulls, you see those 4 points, we will have Interceptor Technologies, one based on how seagrass communities have designed themselves. And you saw an example of that simulation in the little fish farm at the Intervale that was growing the tilapia just a few minutes ago. And then the second is oyster reef technology that the water will flow through. And these will be made up of tens of thousands or even hundreds of thousands of filter feeding animals like oysters and clams. And we're modifying for these a technology that's used in mollusk culture called upwellers, and adapting that into this position. And then the third technology is the kelp forest, which is we will be using an artificial material to create a simulated kelp forest. And then finally is the algal turf community, which will be made up of real living organisms, these sort of Lilliputian forests of these gorgeous little algal species that attach themselves to substrates. And the idea that as this boat, we hope, will travel through the water at about 3 miles an hour. And it has to go 3 miles an hour to treat 1 billion gallons a day. And without those things hanging down between the hulls, that boat would go well over 20 knots or 25 miles an hour. But as it stands, it has to move through the water. We've got some back-of-the-envelope calculations, and it looks as though 100 of them could significantly impact the surface waters of the Gulf of Mexico, and 1,000 of them could probably begin to restore it, and if patrolled around the clock along the shores, could help ameliorate the damage of the nutrients passing from the Midwest and the plain states and what have you down the Mississippi, the Missouri, Mississippi, and into the Gulf of Mexico, where currently it's creating a dead zone because of nutrient excesses that produce algal communities that proliferate and then die. I said I would only talk for an hour, and it's an hour. But I think what I want to leave you with is the thought, the idea that if you can find in your lives some little piece of the planetary stewardship, and as McClarney said, put your shoulder behind it and have a hell of a good time doing it while you're doing it, then that's the thing to do. Thank you.